Hey guys, in this video I'm going to talk about the node selector and affinity rules in the Kubernetes. The affinity rules in Kubernetes includes like pod and node affinity and anti-affinity. And essentially these features helps us to gain more control over our pods, like where this pod should be deployed, in what kind of worker nodes this pod should be deployed. Now let's talk about like why we use these node selector and affinity rules. We will also talk about the use cases of using each one of them. Finally, we will take a look at the practical demonstration. Now let's talk about why we use this node selector and affinity rules. Kubernetes normally makes the scheduling decision on its own, but sometimes what happens is the default scheduler doesn't know our application specific requirements. Let's say I have a workload that is running in my pod should be deployed in a particular worker node that has the disk type as SSD, or the worker node should be CPU or GPU intensive worker node. In that case, my default Kubernetes scheduler doesn't know the requirement. So that's where this node selector and affinity rules comes into the picture. By leveraging these features with the labels that are assigned to the nodes or the pods, we can achieve this. This node selector. The purpose of the node selector is basically to deploy our pod on a specific node that has the matching label, but it is pretty much limited compared to the affinity rules. And the node affinity, this comes with little advanced features compared to the node selector, like it supports the flexible rules, it also supports the operators. The flexible rules are like required during scheduling, ignored during execution. The other one is preferred during scheduling, ignored during execution. One is hard enforcement, the other one is soft enforcement. And the operators that it supports, like in, not in, exist, does not exist, less than, greater than. So these kind of operators we can use in node affinity and anti-affinity. So when it comes to the node affinity, let's say like I want to deploy the pods on a certain worker node that has a matching label, right? Exist or in or less than or greater than. So these kind of operators I can use. And when it comes to the flexible rules, like required during scheduling and ignored during execution, or preferred during scheduling and ignored during execution, these are used based on our requirement. The first one, required during scheduling, ignored during execution. This is mainly used when we want to deploy a pod that has matching label of the worker node. And if it does not find the matching label of the worker node, then it will not schedule the pod in any of the worker node. But the second one, preferred during scheduling, ignored during execution, this is kind of a soft enforcement. Let's say in the worst case, if it does not find a matching label of the worker node, it will try to deploy the pod whatever is available, but it will try its best to find the suitable worker node for it. Node anti-affinity, it is exactly opposite to the node affinity. So in this node anti-affinity, we use the conditionals like does not exist and not in. And when it comes to pod affinity, this works at the pod level based on the pod labels. So let's say like I have an application that requires low latency, the better pod communication. In that case, I have to deploy all relevant pods at one place. In that case, I can use this pod affinity. This pod affinity helps us to deploy our pods at the near to the relevant pods based on the labels of it. And pod anti-affinity, this exactly opposite to the pod affinity. Like this ensures, okay, this pod should not be deployed near to the relevant pods. This is used for high availability. But the pod affinity is used for better pod communication and low latency applications. We can use this pod affinity basically for database pod communications or any kind of backend pod communications or front end pod communications. We can use this pod affinity. And for distributed workload or high availability of the applications, we can use this pod anti-affinity. Now let's take a look at the practical demonstration. All right, I'm in my Minikube Kubernetes cluster. So let me show you the resources that are running kubectl get pods. Nothing is running. Kubectl get nodes. I'll show you my worker node. This is my Minikube worker node. I'll show you the labels. Hyphen show hyphen labels. So these are all my labels of worker node. So let's play with our node selector and affinity. For that, I have already created the YAML definitions to speed up our practical demonstration. I will walk you through all these code YAML definitions. So as you can see, this is my very simple pod definition. with node selector environment matching dev. So what it does, as soon as I deploy this YAML definition, the kube scheduler will try to match this label environment equal to dev. If it has the matching label, then pod gets scheduled onto the worker node. If not, then the pod will be in the pending state. So before we go ahead and deploy, let's first check the labels of it. I have no label that is env equal to dev, so pod should not be deployed. Now let's go ahead and apply kubectl apply hyphen f node selector YAML definition. The pod is created, so let's go ahead and get pods. As you can see, this is in pending state. Now what I will do, it has matching label as app equal to web app. So let me replace app with the value web app. I'll save it. Before go ahead and deploy kubectl delete pod, my pod name. Okay, I'll apply it again. Now pod is created, kubectl get pods. As you can see, this is running now because it has a matching label as app equal to web app. So that's how the node selector works. Now let me go ahead and delete kubectl delete pod, our pod name. Now let's discuss about the node affinity. As I said, it does support flexible rules as well as the conditional. So this is my flexible rules. This is my hard enforcement, meaning if it does not find the matching label with the key of this one with the value this one, then the pod will not be scheduled. Otherwise, if it finds, then the pod will be scheduled. So let's go ahead and try to deploy. As I mentioned, it does support all these operators, and out of all this, not in does not exist can be used for anti-affinity. We will discuss that as well. Now if I go ahead and deploy this one, kubectl ctl apply hyphen f node affinity, my pod is created, kubectl get pods. It is running now because it has a matching label. Let me show you. Kubectl get nodes hyphen hyphen show hyphen labels. So the label it is looking for kubernetes dot io dot hostname. Let me copy it and search it with this one. As you can see, minikube. The value is minikube. It is matching. Operator is in. Even we can use this exist or some other operators. If it is a numerical value less than greater than we can use. So that's how we can use. And on top of it, if we want to use the node anti-affinity, it is pretty much simple. If we keep it as not in, it will act as node anti-affinity. So let's take a look at it. I will go ahead and delete this pod, kubectl delete pod. First I'll delete this one. What is my pod name? Nginx GPU. This is right. Now I'll go ahead and deploy it again. Okay, kubectl get pods. It is in pending state. It will not be deployed because of the matching label. So that is how it works. Kubectl delete pod. I'll delete again. Now I'll go ahead and show you the pod affinity. So it is also pretty much simple. The same flexible rules that we are using required during scheduling, ignored during execution, and the matching labels of the pod is app, the value this one. As you know, I have no pods running in my Kubernetes cluster, so it will try to match the labels of the pod that are running, and it will try to place the my this pod near to the other pod that is running. Since I don't have, it will not be scheduled. So let's take a look at this one. Kubectl apply hyphen f pod affinity. Kubectl get pods. As you can see, this is in pending state. It will not be deployed. Kubectl delete pod. Now let's go ahead and take a look at anti-affinity. With anti-affinity, I will show you the soft enforcement preferred during scheduling, ignored during execution, which means it comes with weight. I will talk about it later. And if it does not find this label, it will try to deploy the pod whatever the worker node is available. I'll go ahead and deploy this pod, kubectl apply hyphen f pod anti-affinity, kubectl get pods. I'll go ahead and delete this one, kubectl delete pod I'll delete this monitoring pod. Oh, it is in running state because it is an anti-affinity, right? It's not an affinity. It is an anti-affinity. That means it will try to make sure that the pods are deployed in the worker node that has no matching labels of the pod. So that's where it will be deployed. That's all for this demonstration.